Get started keeping your JavaScript promises, keeping your promises. They say you should never make a promise you cannot keep, right? So what are we talking about here? One of the things I found really hard moving into JavaScript, especially programming on the node, was to get my head around the fact that while programming in Java, and at that time C# and language like C++, was predominantly asynchronous. You make a method call, you wait until it returns a result for you. Life was very simple. You call something, you get a result. You call something, you get a result. But JavaScript predominantly is asynchronous. In JavaScript, you make a call, it says, I'll get back to you. And then eventually it gets back to you with the result. So JavaScript is an asynchronous programming language. From the ground up, a lot of libraries favor asynchrony. So how did we really achieve asynchrony in JavaScript? Well, unfortunately, what we did for that was we used callbacks. Well, sadly though, callbacks sounded to be a really good idea in the beginning, but it ended up being really problematic over time. Let's look at a couple of examples. I have a file here called sample.js, which is pretty empty. It doesn't have anything in here. So I'm going to say over here, fs equals require, and I'm going to simply require fs. That's all I've done. So in this case, I have required fs, and I want to read the current file itself. So I could say read file, for example. Fs is the little library that's going to read the file. But I want to call the read file. Well, I'm going to call the read file. I got to say what file I want to read. I want to read the same file we are in, .js. But then you got to pass a callback. We'll call it as handle. But that brings up the question, what in the world is handle? So constant handle equal to a function. This, of course, we call as a callback. So in other words, you call a function, but you pass a function to it, which is the callback function. And then it says, OK, I'll come back to you when I'm done. So seems like a really good idea so far, isn't it? So in this case, I could simply say called and see if it even got called. Hey, good news, it got called. But then I'm going to ask you, don't look up documentation. Don't look up anything. I want you to tell me what the first argument is and what the second argument is. And that's when the head scratching starts. Is the first argument error, the second the data, or the first argument data and the second the error? And this short answer is, I don't know. Because every single library wants to do something different. Some people want to put the error first, some people want to put the data first, and you're always scratching your head. Which one is it? And you got to keep looking at the documentation for things. So if I said error comma data, and I can print the data.toString, we got exactly the file we started out. This is called being lucky, that I kind of figured out the second one is data. But a lot of times I can't remember this. But that's not the end of the cruelty. That's the beginning of it. Then what happens is, when you get the data, you don't want to print the data like this. You want to send the data to yet another function, which will do the data, do something with the data. And in fact, that function may not want to do things with the data. It may want to give it to yet another function that wants to deal with the data. So in other words, your callback wants a callback. And the callback itself wants a callback. This is called callback hell. Because by the time you write this function, it turns into a monster. And you look at this and you're like, my gosh, what's going on here? And you cannot understand anything that's happening. And the code becomes very infested. It becomes overly complex. Well, keep in mind one thing. This is something we have to develop as software developers over time, a sense of what kind of complexity are we dealing with. There are two kinds of complexity we deal with. One is the inherent complexity, the complexity of the problem domain. You go to a surgeon and say, do a brain operation. That's complex stuff. But there are other complexity which we cause upon ourselves. These are called accidental complexity. By choosing a really bad solution, the same problem may appear more complex than it is. And this is the example of that. Callbacks just infest with complexity. And the more you start using them, the more complicated things become, but without really altering the problem. The problem is exactly the same. And the problem is very simple, actually. When you call something, it does part of the work and sends it off to something else, which does part of the work, sends it off. But the callback says, I'm going to turn this into a hell on you, right? So that's the second problem. A, there's no real good standard. Second, it becomes overly complex. Like, for example, if this guy says, I need a callback, what are you going to do? I'm going to pass a callback over here. But the problem is, this callback won't come in here. So what am I going to do? I'm going to take the callback over here as the first argument. And then this guy says, I'll call my callback and send the data over to it. But the problem is, how do I send the callback over here? I got to say .bind and give him the callback right here. This is going to become just absolutely incredible to deal with, really bad. That's one issue. Second issue is, your callback, by the time you register your callback, the function may actually finish. Then what happens? Your callback is just waiting. For what? Something that will never ever happen. This is like a person waiting to get married and waiting for a perfect love. That's not a smart thing to do. What do? You say, I'm going to find the perfect love. But then you have to time out at some point and say, dude, this is not going to happen. Let me settle down, right? It's like that. You can't wait forever. So what if you're registering a callback and by the time you register, the event is already over? Tough luck. In fact, this is an example of XHR, the XML HTTP request object. If you register after the event has taken place, tough luck. So what do we do when things become absolutely broken? We quietly move on to something better. And JavaScript did not deprecate callbacks because a lot of people are using it. They kind of quietly left it there and said, yeah, those who have to use it, we're going to move on. So what's a promise? A promise is an object, a function, whatever we want to call it, but it is something that's going to resolve or reject. Because after all, what are you trying to do? You're calling a method, but you want to get a result back. But when you're calling a method and you want to get a result back, well, there are two things that could happen. Things could work or things could fail. Those are the only two options you have, right? So a promise starts in a state of where it's not being fulfilled. It's called a pending state. And when a promise is in a pending state, it can go into a resolved state or it can go into a rejected state. So it's very simple to think about, right? You start in a pending state, either you go this way and resolve it, or you go this way and reject it. But here's the beauty. A promise, once it moves to a state, stays in the state forever. It doesn't matter how long, 10 years, 50, hopefully not that long, right? But it doesn't matter. It's going to stay in the state forever. Which means, if you get a promise from me, you don't have to rush to go find out the state of the promise. Because the promise is going to be in that state forever once it gets to that state. So you can register your promise now, you can get it back later, it really doesn't matter. You don't have to be in a rush to get to it. So that's one of the biggest advantages. But there is yet another beautiful advantage of a promise. If I write a function that is synchronous, what am I going to do? You send me a data, I return the data back to you. If I decide to make it asynchronous in the callable approach, what am I going to do? I'm going to say, oh wait, now I'm going to be asynchronous, which means if you send me a callback, I will call the callback later on. You're not going to be very happy now because I want to go asynchronous. As a result, I'm going to ask you to change your code. What if the code is exactly the same, whether I am synchronous or whether I am asynchronous? Wouldn't that be really powerful? With the promise, you don't know if I am synchronous or asynchronous. Let's actually put it in a better way. With the promise, you don't care whether I'm synchronous or asynchronous. I'm going to just give you a promise. If I'm synchronous, I would have resolved it or rejected it by the time you even get it. If I'm asynchronous, you're going to get a pending state, and you're going to eventually resolve it, right? A lot of talking. Let's see how this works. So let's take a look at an example here. So let's say I have a function. Take a really stupid example to understand this. So constant compute, and what does the compute say? Give me a number, and I'm going to return to you a number times 2, but asynchronously, let's say. Assuming this is a time-consuming operation. So what am I going to do in this case? I'm going to take a callback from you, right? Callback. Now what's going to happen? I can say over here, set timeout, for example, and then I can say after 2 seconds. And then in this case, of course, I could say, well, when the time is over, call the callback and send a number times 2. So that's basically what we're doing here to send it afterwards. Is the font size big enough for the people in the back row still? Thumbs up? All right, thank you. If you need it bigger, let me know anytime. So I'm going to say called. So you can see it says called. But then what am I going to do? Well, I'm going to call it, of course. So let's go ahead and call it. So compute, and I'm going to send a 5 comma, and I'm going to send a function. This function gets a result, right? And then in here, I'm going to say output the result when you have the result. And I'm going to say called. When you run this code, what's going to happen? It's going to print the called first, and then 2 seconds later, it's going to print the 10. And you can see the called was printed first, and then 10 seconds later, or 2 seconds later, it prints the result. But this is using a callback. But if I decide to change this into a sequential, asynchronous, what happens? I'm going to return it right away. So I'm going to say, oh, you know what? If the number is less than 1,000, for example, let's say your computation is increasing in complexity. If it is less than 1,000, return number times 2, else go back and do this after the callback. Now we are in real trouble, isn't it? Because if you return it right away, that's going to be a return from this function. If you return it later, I got to get it from the callback. And I'm like, okay, are you going to give me the result here or in the callback? So that becomes a real problem as well. I mean, you could technically say, even if it is instantaneous, immediately send it by callback, but then you are forcing me to deal with callbacks even if it's sequential. We already agreed callbacks are hell. Why do you want to force callback on me hell when it's a sequential call? So that becomes really funny to deal with. Let's revisit this. So let's get back to this function. We will say no more callbacks for you. But then we're going to say something different. We're going to say if number is less than 1,000, return promise.resolve number times 2. Else what? Else return promise dot, in this case, we'll say new promise. And we'll say function resolve comma reject. We'll come back to this in just a few minutes. Don't worry about it right now. So now I'm going to go ahead and call this one. Output compute, and I'm going to say 5. Well, what is compute going to do? It's going to return a promise. But if you look at the promise, it's promise 10. Why is that? Because it's resolved already. Because it's sequential, right? Synchronous. On the other hand, if I were to place 1,000 or 2,000 rather, what's it going to do? It got a promise which is pending. Because it says, hey, I am not done yet, so I'll get back to you. But look at the code on the caller side. It is exactly the same, isn't it? It was doing exactly the same before and now. If it was synchronous, the promise was resolved already. You got the result. And if it is asynchronous, it was not resolved, and I got a promise which is pending. So notice how elegantly beautiful that is. It completely hides, encapsulates the caller from the callee's concerns. You can get me the result right away if you can, or you can come back later, but I don't have to change the code any bit at all. And this is extremely powerful semantics that you're dealing with. But how do I reject it or resolve it later on? Because it's pending right now. Let's give it a try. So I'm going to go back to this and say compute, and then I'm going to pass a 5 to it. But then I say dot then. So promises are called thenable. A thenable is an object on which you can call this method called then. It means you can take this and say, and then I can do something else. So a promise may resolve or it may reject at any given time. And it may start in a pending state. It may start in a reject state. It may start in a resolved state. We know one thing though, it can only be in a pending state, but once it moves into resolve or reject, it's stuck. It cannot go back and forth. So it's in the pending, it comes to resolve. It's in the pending, it comes to reject. Or it stays in the pending and says, I'm never going to resolve or reject. That's perfectly fine too. But in this case, what I've done is I said then, when you get me the result over here, I want to go ahead and print the result. That's all I'm interested in doing, output the result. Now when I run this code, it said 10. But this is synchronous. It immediately gave me the result. And I'm like, cool, thanks. And I processed it. There's no wait time at all. On the other hand, if the value is greater than 1,000, what's going to happen? Let's roll this into a function. Let's roll this into a constant call compute, which is going to be a function that takes a number. And I'm going to simply move this code inside of this and then pass a number right here. And of course, I'm going to call compute in this case and pass a 5 to it. And of course, it prints 10. But I'm going to also call compute now, but I'm going to send a 5,000 to it. But what is it going to do? It says, well, if you came in here, what I'm going to do is the following. I'm going to say, let's say if number is greater than 0 and number is less than 1,000. So what do I do now? Well, I'm going to say, all right, thanks for coming here. And I'll say, well, if number is greater than 0, I will say set timeout, and I will resolve it eventually after a 2-second delay. In this case, I'll say, when the time is over, what do you want to do? Well, resolve number times 2. So in this case, if the number is greater than 0, I'm going to resolve it eventually after a 2-second delay. Of course, I'm calling set out, which is silly, set timeout, which is silly, but the idea is you're going to do some real work, right? Some computations. Otherwise, what else? Set timeout again, but this time I'm going to say reject, no negative, please. And then after a 2-second delay. So how's this going to work? Let's come down here and let's call compute with, let's say, a -5 and see what's going to happen. But let's take baby steps. We'll come back to these guys a little bit later. So to run this, I'm going to go to the command prompt because it's easy to see the time delay while we work on it. So let's give it a try. So go to the promises, and so right there is the sample.js that we are just working with, right? That code sitting right here. So I'm going to run node sample.js. Bam, immediately 10, because it was synchronous. Make sense? That's because you give a 5, it says, oh, 5 is between this range, there you go, I resolved it. And because you resolved it, by the time you got here, it's already been resolved. So that then says, hey, we're ready to fire, let's go. On the other hand, I'm going to give a 5,000. When I give a 5,000, what's going to happen? It comes in here and says, oh, that's greater than 1,000. Here, call this promise. What's the state of the promise? Pending. When the promise eventually resolves, the then is going to be called, not until then. So when a promise is pending, the then is just waiting in the queue. When the promise says, I'm done, the then is going to get called. So in this case, after a 2-second delay, that should fire up. Let's see if it's true. So 10 on the first call, 2 seconds later, 10,000, because that's when it got resolved. Let's do a little bit further. In this case, I'm going to say -5. That's a rejection. Sorry, I don't like it. No negative, please. Step back to callback. What was one of the confusion in the callback? The first confusion. Yeah, which is the error, which is the data. How do you feel when you have a situation like this? You feel like an idiot every single time you use this, right? Especially when you use 7 different libraries and they all double it up. You're creating a cheat sheet in front of you, right? Cheat sheets are nonsense. Why should I choose a cheat sheet? What if APIs are intuitive? I don't need to cheat anymore, right? So when you design API, the sign that an API is bad is when the developers release a cheat sheet for you. That's a sign. Because what is it? This is complex, so it's a cheat sheet for you. Like, why don't you make it simple so we don't need a cheat sheet? So the point is it's got to be absolutely trivial, intuitive to understand. And what is that? Well, we say over here, if did not go well, catch error. And I'm going to print the error. In fact, I'll print the word error, colon, and then I will print it. How about that? So, of course, I'm not going to use the -5 yet. So go back and run this. You got the instantaneous result. You got the positive result. So what happened? That catch did not play a role at all. Here's the beauty. If I'm a promise, I've got 2 arms. I've got my data arm and I got my error arm. Just like we do. There's a meaning between right and left, right? So we do eating with this, and you know what we do with that. So the point is we got 2 different arms. That's exactly what promises do. If everything goes well, I'll give you the data. If something else comes out of it, I'm going to give you the catch. So there's a track that goes on with it. So when a promise resolves, you get the data through the then. When a promise rejects, you get the data through the error channel. Make sense? So there are 2 clear channels with you. There's the then channel and then the catch channel. So right there is the then and there's the catch. And the beauty of this is, now when I come back here, what's going to happen? Well, you get back the promise from here when you send a -5, and on this line, what is the state of the promise? Pending, that's right, you've been paying attention, good. It's in pending. Eventually, it's going to either reject or resolve potentially, and when it does, if it's a reject, you bypass the then, you come to the catch. Is that true? Let's run this. Success, success, error. So you can see how that came back as an error, no negative. Now you may wonder why those 2 came immediately, because we made 2 calls, and both the calls were 2 seconds apart, but because we didn't wait for the first one to finish, the 2 seconds were actually at the same time, right? So that's why they worked really quickly. But notice how you got the rejection very nicely through here. So this solves one of the first problems. You don't have to know about which way it is, error or data, data or error. No, it's very clear. Data is through the then, error is through the catch. Hey, wait a minute. What about composing? If my callback has a callback, right? Then what happens? Well, composing was a nightmare when it comes to callbacks. We don't have to go through that kind of nightmare. Let's go back here and say, well, if everything went well, then, well, don't print it here. Take the result, please, but return a result +1 for me. And I'll take the result +1, and I'll say result, and I will print the result that you give me over here. So I'm going to say output the result. So I'm going to output the result. Let's only work with the 5 for a minute. So what happens when you work with the 5? You send a 5, it immediately returns to you 5 times 2, which is 10. What is this guy going to do? He says, thanks. You gave me a 10. I'm going to add 1 to it, which becomes 11. But it's a success. So I'm going to move on to the next to then. So the thens connect the thens. The catches connect the catches. Make sense? Very logical, right? No confusion. Very well laid out. So I've got a then, I'm positive, I'm then, keep going on the right arm. If everything is going well, keep going on the right arm. If things are not going well, go on the left arm, right? So it's just moving forward. So in this case it says, I'm going to print the result after you add 1 to it. Let's see if that works. There's 11. So logically what happened was, this guy doubled the value, So as a result, you got a 10. And this guy says, I am the next promise in the chain. I received the value 10, and I'm going to resolve it so you can pick it up. So there are multiple promises receiving and resolving here. So you are a promise, you resolve, I get it from you, but I'm in turn a promise and I resolve. And you can go forward. But what if I don't like what you just gave me? So here, I'm going to say, I don't like the fact that you gave me twice the 5. So what am I going to do? Throw. New error. I don't like it. So what did I just do? I just blew up. When I blow up, what's going to happen? You are in the right arm because the promise resolved. What does the right arm do? It says go over to the left. I don't like what just happened. So now you're on the left track now from the right track, right? If you notice, you went this way. The next promise says, sorry, shift over, right? So you move the track and then you say, this is what happened. I resolved it, but this guy says, I don't like it. The second guy in the chain. So go over here. So where should it go? Well, because I rejected it, it's got to go to what? Catch and report the error. Because you went from resolve to reject. So by throwing an exception, you can go this way. Likewise, this is not entirely true. This guy's not blowing up. So this cat says, look, you blew up, but I'm going to correct it. It can put you back on the right track. So you could do this too. So, there are times when you receive an exception, and then you amend it. And then you're like, I'm recovering. I can move forward now. So as long as you're throwing, you keep going on the catch. As long as you're succeeding, you're going on the right. Anytime you throw, you go this way. Anytime you don't throw, you go this way, right? So catch doesn't mean it's the end of the story. A catch may recover the problem and move forward as well. It really depends on what you're doing, and it can vary depending on the situation. So notice, error, I don't like it. So what is going on with the error, I don't like it? Well, this guy threw an error, and that error object itself, in fact, if I say throw, I don't like it, without the error, let's just throw that one. Now that error wouldn't come through, and when I run this, you can see error, I don't like it. That error is because this guy prints the error. So notice how from this then, we went to this catch. So the moral of the story is, you got a nice good track and a bad track. And as long as things are going well, you keep going on the good track. When things don't go well, you go on the bad track. But again, on that track, you got to decide where to go also, and we'll see that in just a few minutes. So you may then handle the response or catch the failure. You may settle or you may reject early or resolve early. So the three statuses are pending, fulfilled, and rejected, or pending, resolved, and rejected. That's what we saw so far. So, yeah, please. Yeah.
One quick question.
Please.
So after then it completes, or if a then throws an exception, the flow would immediately go to the nearest catch.
Next catch. Next catch.
Okay. So if we had two thens in a sequence, and the first one threw an exception, it will still go to the catch and not the next then.
That's correct. Because think of it as a track, it becomes easy. Right? Something failed. You have altered the track. There's a track here still, but the train is not going to go there anymore because you had the foreman move the bar, right? So the train comes in and goes that way. So that's why the track analogy seems to work really well, at least for me. So here's a good track. There's more track here, but I can't go there because I found there's something wrong. I'm going to send you on the bad track. Yeah, please. Because you didn't throw. So if you don't throw, so we'll see that in here. So let's try this. So the question was, how do you then go to the then? That's why it said undefined in the end. So if here, just for the purpose of this example, right? When you give me an error, I'm going to throw, and then what am I going to throw? Error dot to uppercase. I'm just going to make it uppercase and throw again. Now this time, this will not go into this catch. Earlier it did. And what did console return? Undefined. That's why this guy printed undefined. But now I blew up again. Now I'm saying, I know you failed, but my job was to take the exception, turn it into uppercase, and throw it again. So you're in the fail track. Because you threw, it stays on the fail track. So to be on the fail track, it's got to be throw, or reject. To be on the good track, it's no throw or no reject, right? So in this case, it will not come into this. So what am I going to do? I'm going to come down here, and I'm going to put another catch. Error, and I'm going to print here, colon, plus error. Well, notice, the data was good, because it gave us a 10. This guy said, I don't like it, so I'm going to blow up. This guy said, I don't care you blew up. I'm going to take that and turn it into uppercase and blow up again. And this guy says, I don't care who sent this to me. I'm just going to print it with a here. So when I go back and run this here now, oops, so that blew up. That's because this is lambdas. So put a little curly around him and try this again. Okay. All right, where did I go wrong? So this is going to finish here. Oh, you don't like the extra colon? Okay. All right, let's remove that. Thank you. So let's try this again. Here, I don't like it. So notice how it was success, failure, failure again, report the failure. Now what happened on line 8? On line, oh, by the way, promises result in promises, result in promises, result in promises. And the last promise, guess what happened? Disappears. Nobody cares about it, right? Because there's no receiver after this. So the promise just bounces off and says, hey, anybody cares that I made a promise? There's nobody around. It's like, okay, I'll just go away. So there's nothing to receive it. So this was a success in the very end, but didn't matter because there was nobody to receive it. Because at the terminal, we just printed it, right? At this point, we don't care. Had you put a then and a catch after this, would you hit the then or the catch? Then, because this didn't throw. Right? So keep in mind, rejection or throw, you stay on the left. No rejection, no throw, you stay on the right, on the then. So how do you use this? You can use a new to create a promise. You saw me do this already. When do you use the new? You use a new when you want to return a promise of what status? Pending. I can't decide now. So I'm going to wait until later. So I'm going to give you a new promise. If I know that I'm going to accept it, what should I call? The resolve. If I know I'm going to reject it right away, I'll call reject. We saw these three, right? So you can reject right away, resolve right away, or you can send me a pending. And then when you send a pending, what do you get? You get a function that will be resolved later on. If you really wanted to, you could have written it this way also, as a lambda. That's perfectly fine too. So I just made that one change alone, nothing else. That works. So you could do that too. In this case, of course, we didn't call it anyways. So that could be fine as well. So you can create it. Catch is a special form of then, which has both of these. So let me show you an example of what I hope you will never do. And that is, you can go back here and say, in this case, then result is equal to result, comma, error is equal to, and then I'm going to output, let's say in this case, oops, colon, plus error. So in this case, we use the then for both. So if I run this, you will notice that it's at 10. But if I come back and do this one and this one, what's going to happen, of course, as you would expect is, it accepts the first one, rejects the second one, as you can see here. But one thing to keep in mind here is, you're using the then with both of the parts. So in this case, the then has two parts in it. The first is the good part, the second is the rejection part. While this works, I will highly recommend not to do this, because the code becomes a little cluttered. I would rather use the then and catch than do this. If you do this, you'll make me a very unhappy reviewer when I review your code. So just because we can do this doesn't mean we should do this, please. If there was a throw before me, then will not be called. If there was no throw, then will be called.
Okay. If that throw is there, then another catch will only can catch.
If there's a catch, it will be catching it. If there is no catch, depending on the environment, you may get an error saying, hey, look, I had an error propagating, but nobody cared to handle it. If you don't handle the data, they don't complain about it. Because if you don't handle the data, you're not going to get the proper output. So eventually you're going to fix it, hopefully. But if it's an error, it's easy to miss it. And that's why they will complain. We'll see that in a second. So in this case, if it's a good one, it is handled. If it's not, it's going to report that, and it's failing. So we saw this working. But what is a better approach than this? A better approach is to terminate that then do a catch right here, and do whatever you want to do in the catch. These two are equivalent to what we did a few minutes ago, right? So let's go ahead and try this. So if I go back and run the code, the behavior is no different at all. It's exactly the same. Now to come back to your question, suppose this guy is going to blow up again also. He says, I'm going to say throw, and what am I going to throw? Error.to uppercase. Well, first of all, let's try something else. He says, return error.to uppercase. Just watch this for a second. What's happening here? If you send a 5, it got the result it printed. If you send a 5,000, it got a result it printed. If you send a -5, that was a rejection. So what does this guy do? He handles the rejection, converts to uppercase, and that promise turns into what? Resolve. So the promise is a resolve after this line. And once it resolves, what does it do? It bounces up and says, I'm a resolved promise. Anybody cares? And nobody does. And the promise just disappears. Say that again? Well, because you didn't reject it. You didn't throw. Well, a throw is a reject. A non-throw is a resolve. Or you call reject directly. Did you call reject? No. Did you throw? No. It's a resolve. And we'll see that also in a few minutes. So what's going to happen in this case? When I go run this, you're going to see the 10. You're going to see the 10,000. But there's a reason why you didn't see the error. Why didn't you see the error? Because the error was consumed, resolved after the error. However, exactly the code, but I put a word throw in front of it. Now what am I saying? I'm going to convert it, and I'm going to blow up. Now it became a what? It came in as a reject, and it leaves as a reject. When it's a rejected, there is nobody caring about rejection, right? And in this case, Node says, oh, wait, this could be a problem. So run this code, and what's happening in this case, unhandled promise rejection warning. It's a warning, right? Hey, do you realize your code just blew up, and you don't have a catch to handle it? Did you really mean that? Right? And that's giving you the error. So that's one way. But let's go back to what you can throw or how you return these things. So there are a couple of decisions you can make. So let's start over with a little example. Yeah, please.
So previously where you had the accept and the reject in the same then block, if the accept throws, does it go in the error block? in the
Really
itself?
good question. Really good question. That's another reason why that's a bad thing. So, excellent question. Give me a high five from there. There you go. So, when you have a then with the catch right there, you have missed the opportunity of the catch. You're not going to come into it anymore. So that's another good reason why you may want to really bring them this way. If you don't want this catch to ever play a part of this failure, then you may want to put it in the same then and as two things. So that may be the exception to the rule of me hating it, right? So if you say, oh, this or this versus this. So it's literally, that's a way to look at it. You're on the same line versus you're on the second line. So this will flow through, whereas once you come here, it's not going to go horizontally, it keeps going down. It's a pipeline. So very good observation. Excellent. Yeah. Now, let's look at something else. I'm going to get a promise and work with it. So I'm going to call compute, and I'm going to send a 5 to it. Well, in this case, I'm going to then take this and say then some function f1 I'm going to call. So data, I'm going to call a function f1 and pass the data to it. And then I say then, let's say result, and I'm going to print the result. And in this case, of course, and if something were to fail, catch, error, and I'm going to simply print out, oops, and then I'll print the error. So there you go, error. Okay, so far so good. But now, what is f1? I don't know. We'll find out. Well, the compute function says, function, give me a number. And what am I going to do? I'm going to simply say, return a promise dot resolve, just the number. No big deal, right? Let's talk about the function f1. The function f1 says, you're going to give me a data. Okay, thank you for giving me a data. So function data. And what am I going to do with this data? I'm going to simply return the data you give me. So in other words, the then calls a function which returns the data. So when I run this code, it simply printed the data. And I will put here for our purpose result colon plus, so you can see where it got printed. But it went through this guy. So I'll go ahead and say f1 called, right? So what's the moral of the story? If a then returns the data, that promise does what? It resolves it. If a then returns the data, it resolves it. I can change this. I can say return promise dot resolve data. I don't have to return data. I could return a promise. Why? Because my function is already implemented. It's returning a promise. And you want to use my function in your call. And you're like, wait, you already returned a promise. What gives? What do I do? Well, no worries. You just call my function. If my function returns a data, it becomes a resolve. If my function returns a promise, what do you think is going to happen to this promise? Are you sure? It is whatever that promise is. Right? If I return a promise, your promise will do what my promise does. If I resolve it, you resolve it. If I reject it, you reject it, right? So that can follow through hierarchy. So in this case, I am resolving it. So run the code, f1 called still, and result is 5. That shouldn't be a problem, right? So what is the beauty of this? Your function can either return a data or it can return a promise. Well, I'm not too happy with what just happened. So what am I going to do? Return, well, in this case, I'm going to say throw. And I'm going to throw, sorry, don't like it. So I'm throwing, sorry, don't like it. So when my function blows up, he says, oh, so sorry, you threw an exception. I'm going to put you on that other track. It automatically takes the then and sends it to the other side, right? So that works that way. What if I say return promise.reject? Uh-oh. Because you rejected. So there are three options, right? Your function can return a data, reject or resolve, throw. Those are the three options. Either you can return a data to me, you can blow up, or you can return a promise which rejects or resolves. If you return a data, it's a resolve. If you return a throw, it's a reject. If you return a promise, it is whatever the promise does, right? That's what it does. Somebody had a question over there. Yes, sir. Maybe. If I'm synchronous, I'm a return a result or a rejected promise already. So the question is, can you cancel a promise? That's not up to you. That's up to the person who's going to throw it. I know what you're trying to do. I know what you're trying to do. You're thinking back on the timeout I said. That love that we are waiting for, that's never going to happen. And you're like, time to time out, right? There's no accident. The answer is no. But no doesn't please you, is it? So we'll have a workaround. So wait for a few minutes. We'll come back to it. Good question. I don't have an answer yet. But don't time out yet. I'll come back with an answer in 5 minutes. Yeah.
So for my question, you said like if you have already the data like resolved state already ready, then it's synchronous, right? But is it really synchronous? Because when you showed that call compute 5, it returns 10.
Right.
If you put a console log before and after that,
Yeah.
you say the console logs first and then.
That is true. And the reason for that is the promise says, hey, you know what? If you call me, I'll come and call your then. But it doesn't call the then in a rush. But that call to that function is still synchronous because you got a promise right away. But it's so that the function has folded up and gone home, right? The function says, my job here is over. And now you're holding on to a promise. In an asynchronous situation, what happens? The function is still active. Its state is valid. Whereas here, the function has gone home. You get this promise, you turn around, hey, where's the function? It says, I'm sorry, I'm done. Everything I have to do is over. You're holding on to a promise, but that's your problem now. He'll give you the state. So it's a fuzzy way. It depends on how you define it, right? Now, he says, yeah, but I called a promise. It's not resolved. What gives? How long am I going to wait, right? Fair point. Let's come to that. So I'm going to go back here. And I'm going to say, give me a new promise. So return a new promise. And this says two functions, resolve, comma, reject. And what does this do? It says, if number is less than 1,000, resolve number. So, and I could even do after timeout if that pleases you. So set timeout. So set timeout and give me 1 second, and then I will resolve it. So resolve the number. So far so good, right? So let's see how this is going to work. So I call compute, send 100, and I say dot then data, and what am I going to do? Output data. So that one is good, isn't it? So after 1 second, it printed 100. What if I'm going to give you 10,000? What do you think is going to happen here? Is it going to reject? Is it going to resolve? It's in a limbo, isn't it? It's going to just wait and not resolve. And in this case, he said, I'm done. There's nothing here to wait or get back data. Because this guy said, if it's less than 1,000, I'm going to do this. Otherwise, poof, out. But what if this is going to take a lot longer to get back, right? Whether we don't know if it's going to reject or resolve, or what's going to happen in that case. So what if it's going to take a lot longer to decide? What if I had said, in this case, let's put it a little bit better, even better. Set timeout, and I'm going to say, in this case, get me a function, and after 1 second, let's say 2 seconds, I'm going to say if number is less than 1,000, then resolve that number, otherwise don't resolve it. So again, if I take 100 right here and run this code, well, this guy says, I'll wait for that 2 seconds or whatever, and I resolved it, so it printed 100. If I print 10,000, what's going to happen? Run this, he's waiting for it to resolve, isn't it? And in this case, he was smart enough to know that it did not resolve in the end. But that may not happen, because that may take a lot longer. And who knows? You don't know whether it's taking longer or it's a goner. Right? You know how we have these hope, right? Wait another minute. Wait another day. Wait another year. In the meantime, the beard grows, we're getting older, right? At some point you're like, do I wait a little longer or do I time out? That's always the point. So what do? Here's an idea. Now you know the purpose of raise. Pick a promise that is going to be fulfilled or going to be rejected. Whichever it is, that's going to be first. So I'm going to give you 2 promises, let's say, but you're going to put them to a race. You're going to get back the first one, whether it's a reject or a resolve, doesn't matter. To understand this, let's take a slightly different example. I'm going to take a number, and hopefully not such a big number. And when you give me a number, I'm going to come here and say, set timeout, and in this case, I'll say, resolve the number. But after number times 1,000 seconds. So I'm going to say 1. That will obviously resolve after 1 second. If I say 2, it resolves after 2 seconds. Well, but what if I don't want to, wait for both? I just want one of them. Promise.raise. Compute 1, compute 2. And then, of course, once I do this, what am I going to do? Well, in here, dot then, and I'm going to say data, and then what am I going to do here? Output the data. So run this. What's going to happen at this time? Well, when I run this, it says it was not handled. What happened? Let's see. So resolve, set timeout. So raise, compute 1 and compute 2, then data, and then simply resolve the data. Does anybody see where the rejection happened? So compute is being called. It returns a promise with a resolve or a reject. And then, of course, in this case, when I say set timeout, I'm going to say, well, after the time period is over, simply resolve that number and return it for me. And this gets over right here, and this gets over right here. So I'm not sure where that came from. So in this case, of course, we're going to call the raise. It's a pick up a promise that fulfills or rejects it. If no promise is given, then promise is going to, there we go. So square bracket, array. So it gave you a 1. Notice, I changed this to a 3. What's going to be the result now? A 2, but after how long? 2 seconds, 1,000, 2,000. There we go, 2. Make sense? How can we use this? Now you tell me what your timeout is. So notice what I'm going to do here. See if this makes sense. I'm going to say constant timeout equals function duration in MS. What am I going to do here? Set timeout, give me that milliseconds. And what do you think I'm going to do here? Return a reject, right? So new return, new promise, resolve, comma reject, and in here, of course, we're going to say set timeout, move this in here, and this is going to be reject timeout. So what's going to happen in this case? Well, I'm still using 3 and 2, but I'm going to be impatient. So comma timeout 1000. Now what's going to happen? 1 second it's rejected, isn't it? 1 second later, I better put a catch. So what am I going to do here? Catch, error, output, error. So just for the fun of it, let's go ahead and try this out. So I go here and say run. 1 second later, timeout. I'm done. I'm not going to get any of the other data after this. On the other hand, if I make this a 4000, a bigger timeout, the 2 is going to resolve by then, and so I get 2, as you can see. So the moral of the story is, even though there is no way for me to reject it, I can build a timeout on it using the race and say, I don't care what you're doing, but I'm going to give you this much time. And either want a result in that time, or I'm going to time out and go on, right? That gives you a way to do this. So, we saw the chaining, we saw that then any exception propagated. I think we finished this already. That brings us to one other detail which is pretty darn cool, which is promise.all. So what is promise all? You saw raise. What does raise do? That's right, pick one. Which one? The first one, which resolves or rejects. All says, I'm going to wait until all of them resolve, or one of them rejects. It's like your AND operation, right? All of them resolve or one of them reject. So this is useful to do multiple operations. Let's see if we can use this in an example real quick. So I have a file sitting here which is called numbers.txt. I want to do some operation for each of these numbers. So what can I do? Well, remember our good old friend fs? So constant fs equals require fs. Do you like fs? Did you really like it? Because the minute you use it, where does it take you? It takes you into the callback hell. So we don't want that, right? So what can we do? fs promise. So fs promise is another library that simply wraps promises. fs using promise. If you want to, you can use fs promise. You're saying, okay, this is cool, but I got my own homegrown functions which came from the callback hell. I don't have time to change it to promises. What can I do? There are a few libraries. One example of that is called a library called Bluebird. If you use Bluebird, Bluebird will take your existing callback hell and nicely wrap it with promises. So either you can use homegrown solutions, specific solutions like this, or you can use solutions like Bluebird. So take a look at Bluebird if you want to just take any arbitrary function and wrap it into a promise. So in this case, I'm going to say sample.js. Then data output data.toString. Let's start with this first. So this is using a promise, right? So beautiful, isn't it? What if I make a mistake? .catch, error, output, oops, colon, error. So that's working. But what if I say SAMP, error, no such file with the oops. So notice how beautifully that handled a promise. So fs promise, you got to install that separately, but fs promise gives you that. Now what we can do is the following. I'm going to call this as, what is it, numbers.txt. So numbers.txt. Then, I'm going to call a method called split lines. Let's take baby steps. So what in the world does split lines do? Constant split lines equals function. This takes lines and it returns lines.split on a /n. So what can I do now? I can say then data, and I can print the data that I got here. So in this case, rejected. What did I do? Numbers.txt. So did I call it correctly? Numbers.txt. Yep, that's what I'm using here, numbers.txt. So then I'm saying, given the lines, let's actually take baby steps. Let this return lines itself. So that's the lines. Now we know why. I need to convert to a string. Then, convert to string. So what am I going to do? Constant in over here, right? Convert to string is equal to, well, what does this do? Given the lines, it's going to return lines.toString. Then, of course, this can then say .split and give me a /n. So I can convert this to and get that, right? So once I split two lines, this is going to split on those. It gives me an array. Then what can I do? Well, I can perform a map operation on the collection, isn't it? Map. And I can say, then, this is going to be the lines, and I can say lines.map, and I can work on every single line. But at this point, what am I going to have? Multiple arrays of things to deal with. That's a great time when I can call promise.all. So promise.all, and then I can take the lines, these are the lines, and then I can say lines.map and perform a transformation on the lines. Take every single one of the line, and I can wait for them to resolve. So this will say, I'm going to wait for every single line to be processed and give you a full result when it's done, or I'm going to give you a first rejection. So one last thing before we wrap up. We only talked about promises. In the rest of the conference, you will hear about reactive programming from other speakers and a little bit from myself. What's the big difference then? Well, structurally, they're going to look very similar. A promise is a propagation of one piece of data. So if you line up promises, I send ping one data, it's going to go through. An observable in reactive programming is a stream of data. So I'm going to keep emitting any number of data. So the main difference between these two is a single data versus a stream of data. So if it's a single data, use a promise. If it's a lot of different data you want to stream through, you may want to use RX observable, which happens to be my next talk if you're interested in that kind of stuff. Hope that was useful. Thank you.